What would I have to multiply by to clear my fractions? Yeah, because of the plus in here, you have to use both of them, x and x plus 20. And x plus 20. So if we cancel off our x plus 20s, we're left with 600x. If we cancel off our x's, we're left with 360x plus what? 7,200. And once I move things around and solve this, what do we get for our answer for x? 30 miles per hour. So let's go back to our chart over here. That means the freight train was going 30 miles per hour, and the express train would be going 50. Or 50. So the two answers we wanted are 30 and 50. These are mighty slow trains for express and freight, so that's what we get. Okay, and that was their question, wasn't it? Let's see. Find the rate of each train. Okay, the next thing we want to do is to look at some different type problems. Still same setup. Still same three things to think about. But in these, we're going to have current and wind to consider in our traveling. We're going to have some problems that are going to involve a boat that's either sped up or slowed down by the current. And then we're going to have some plane problems where the wind's blowing and the plane's either going to go faster or slower depending upon what the wind's doing. When you go on a trip sometimes and you're flying, if the wind's blowing with you, it makes you get there quicker than they really say you're going to get there. If they hit some turbulence or hit wind and the wind's against them, might slow you down. So that's the type of thing we're going to be working with in these problems. So problem number 4, it says in a total of 8 hours, Justin paddled a canoe 15 miles down a river and back. If the river's current was 1 mile per hour, find the rate Justin paddled. So this problem is going to be a boat problem, and we're going to have to deal with the current. It's talking about Justin going down a river and back, so we're going to talk about, I'm just going to say downstream and upstream for our two categories. How far downstream does it say that he goes? 15 miles down. And he comes back. So what would you guess the upstream would be? 15. So in other words, this is just saying he's going to a destination, he's turning around and coming back. Now, and it tells us that the river's current is 1 mile per hour. Now, what's going to happen if you were paddling a boat at a certain rate and you were going with the current? What would that current do to you? If you're going with the current's 1 mile per hour or whatever it is, what is it going to do to you? It's going to make you do what? If it's going with you, it's going to make you go that much faster. If you're going against the current, it's going to slow you down that much. So what you have to do when you do your rate in these is you have to put what you were actually going. I'm going to say it's going to really be the calm water plus whatever the current is. I don't really have much room to write that in this chart. And when you're going upstream, you're going to have your calm speed minus whatever the current is. The current's going to slow you down and speed you up. So we've got to take that into account. Now, what they're asking us to do in the problem is actually find the rate that this person is actually paddling. So the X is going to really be the calm water speed, or his paddling speed. In other words, how fast he would be going if the water were calm. How much speed is he exerting? Or if you had a motor going, what the motor would be exerting. So in other words, his actually paddling speed plus the current is what's got to go in the rate column. And his actually paddling speed minus the current has to go in the upstream problem. So, if we don't know how fast he's actually paddling, but we do know the current is 1 mile per hour, what are we going to put in our rate column here? X plus 1. X for the calm speed plus 1 for the current. And the calm minus the current would be X minus 1. Now, if you will write in your chart, at least the first time you do these with the current and the wind, if you'll write in your chart calm plus current and calm minus current, so you'll remember how to fill those in. Because once you get that filled in, the rest is easy. It's 15 over the X plus 1 and 15 over the X minus 1. Now, you've got to go back and look at the way the problem's worded again and decide which category this fit in. Is it a total, a difference, or an equal to one? Talks about the total. Talks about the total. So we're going to have the down time plus the up time is going to be equal to, what's the total time? What does it tell us? 8. The total time is 8. So let's fill those in. We'll say down plus up equals to 8. So I've got 15 over x plus 1 plus 15 over x minus 1 equals to 8. 15 over x plus 1 plus 15 over x minus 1 equals to 8. So what do we have to multiply by this time? X plus 1 and x minus 1. You're going to get good at these fraction equations by the time you finish doing these distance applications. X plus 1 times x minus 1 by everything. Okay, so when we cancel off our x plus 1s in the first one, we have to multiply 15 times x minus 1, so we get 15x minus 15. Here we cancel our x minus 1s, we get 15x plus 15. And over here, you've got to use the full method on the x plus 1 and the x minus 1, and then multiply by 8 because nothing cancels. So when you use the full method, what do we end up with?
X squared minus 1.
Really just x squared minus 1, because the insides and outsides cancel each other out. So we've got to say that by 8, so it's 8x squared minus 1.
8
So,
minus
8x squared minus 8. Okay, we combine our like terms here, 30x. The 15's cancel, so we have 30x equals to 8x squared minus 8. What kind of equation is this? Linear or quadratic? Quadratic. Quadratic because it's got a square. So we have two choices. We can either factor it or use the quadratic formula. Whichever we do, we have to get it in the right form. So we need to get it equal to 0. So if I move that 30x over, I'll have 8x squared minus 30x minus 8 equals to 0. And can I make my numbers smaller here so it would be easier to try to factor it? What could I do? Divide everything by 2. So I'd have 0 equals to 4x squared minus 15x minus 4. 0 equals to 4x squared minus 15x minus 4. And I'm going to move back over here to our chart and work it out since I'm running out of room. Let's see if we can come up with some factors. Because we have that big number in the middle, we're going to have to use some sort of different factors. It ends up we're going to have to use 4x and x and 1 and 4. We've got to have different signs, and to make that middle term work right, we've got to have a negative on the 4. So when we set these equals, 4x plus 1 equals to 0, and x minus 4 equals to 0, what are we going to get for answers? x will be negative 1/4, and over here, x will be 4. X will be 4.